Hey guys, welcome. Today I want to show you how to aim and shoot projectiles in the direction of the mouse cursor. By the end, we'll have our little character damaging enemies with our ranged combat system, and we can choose from two kinds of ranged attacks. And we're going to do this in the Unity game engine. Let's get started.
Okay, and here's the scene that we're starting off with. This is very simple. We have an enemy in the scene with literally nothing attached to him whatsoever. We also have a player with a player script that lets him move around and jump, and I have added a gun sprite, and I've made that a child object of body. Every single asset that you see in this tutorial is available for you to download. If you want to follow along with this tutorial, I will leave a link to download the assets you see in this project in the description below. You can use them personally or commercially. They are yours, do whatever you want with them. I hope you enjoy. So what we want to start off doing is having the gun rotate towards the mouse position in the world. So in scripts, in player, I'm going to create a new script called player aim and shoot. Let's add that to our player and let's open it up. And let's get rid of this startup stuff. So right off the bat, we need to be checking for the mouse position every single frame in the game. So let's create an update function. And in there, we're going to call some sort of gun rotation method. Let's actually create that. So the first thing we want to do is rotate the gun towards the mouse position. And we're going to do that using Unity's new input system. So make sure you go up here and say using unityengine.inputSystem namespace. So what we want to do is we want to grab the world point of the mouse position and store it in some sort of vector2. So let's create a vector2 up here. Let's call that world position. So down here, we're going to say our world position is equal to our camera.main.screen2worldPoint. And it wants a vector3 position, and we are going to pass in the position of the mouse. So that is mouse.current.position.readValue. So we now have the position of the mouse in world space saved to this world position vector2 variable. So now what we want to do is store an actual direction from the center of the gun to wherever our mouse happens to be in world space. So really a direction is just a line with 2 points, one on each end. And to calculate a direction in Unity, we take the transform position of the second point. In this case, the second point would be the mouse position. And we subtract the transform position of the actual object that we are trying to rotate, in this case, the gun. So we're going to want to reference to the gun. So let's go up here and say serialized field, private game object, gun. And before we forget, let's go ahead and fill that in. And let's create a vector2 called direction. Okay, so now we'll go down here and say direction is equal to our world position minus the gun.transform.position. You'll see this gives us an error. That is because we are trying to subtract a vector2 from a vector3. So what we can do is cast our transform position as a vector2. And we can do that by going right here and just putting in brackets vector2. And finally, to get a proper direction, we need to normalize this calculation. So this direction is a vector2, and by normalizing this vector2, all we are doing is making sure that this vector2 has a magnitude of 1. This means it'll basically clamp the x and the y on this vector2 to 1. It can't go any higher than that. And this will just make sure that we don't get any weird behavior with our direction. Okay, so every single frame we are calculating a direction between the mouse position and the center of this gun. What we want to do is rotate the gun to match what our direction is. And you can see as we're rotating our gun, its transform.right is always facing the direction of the gun. So what we can do is just say gun.transform.right is equal to direction. And you can see now, if we test that, you can see that the gun is definitely rotating towards the mouse position. However, one thing is happening that we probably don't want, which is that if we keep on going this way, he's just going to keep on rotating the gun even though it's upside down, which looks a little bit weird. So let's fix that. So what we want to do is we want to flip the gun when it reaches a 90-degree threshold. So you can see as we're rotating the gun here, we approach in the Z over here, we approach 90 degrees when it's pointing directly up, and we approach negative 90 degrees as it's facing down. So what we want to do is if we go beyond that 90-degree threshold, we want to flip the gun. And we will do that by changing the scale in our Y to a -1 instead. So let's add that in. So let's create a vector3 called local scale. And let's make that equal a vector3.1. That is literally the same as writing it this way. Completely the same either way. And at first glance, this looks like this should be very easy to accomplish. We could say something like if gun.transform.rotation.z is greater than 90, or gun.transform.rotation.z is less than -90, well, then we could set the local scale.y to be equal to -1, else we'll set it to be 1. And then finally, all we have to do is say gun.transform.localScale is equal to our local scale. Let's test that. Nothing really seems to be changing, so something's wrong here. Let's take a look. So if we do a debug.log on our gun.transform.rotation.z, let's take a look at what it's displaying. So when it's pointing to the right, the value is 0, and when we point all the way to the left, the value is 1. So really, this is just swapping between a value of 0 and 1, even though up here we get our actual degrees showing. Working with angles in Unity can be a little bit counterintuitive and a bit difficult to grasp at first. And I think one of the reasons is because what you see in the inspector here is not what matches what's actually happening behind the scenes in the code. So this is not going to work. Let's get rid of this debug.log. What we'll have to do is calculate the angle ourselves. So let's set up a float up here called angle. Okay, and right up here, we're going to say our angle is equal to mathf.atten2. I have no idea if I'm saying that right. So unless you're like a trigonometry wizard, this isn't going to mean anything to you. Returns the angle in radians whose tan is y over x. But what we're going to do is we're going to pass in our direction.y and our direction.x, and then we are going to translate this, because this is in radians and we want degrees. We will then convert this from radians to degrees. So what we're going to do is we're going to say direction.y and then direction.x. And then we're going to multiply this by mathf.rad2 degrees, which is a radians to degrees conversion. Now, instead of gun.transform.rotation, we can just swap in angle. Same for right here. Let's try that now. Okay, here it is. It's facing normally, and as we approach going vertically, it then turns around as it should. And down here, yep, it flips when it should. Awesome. Next, let's handle the gun shooting. So we're going to throw that in our update function. Handle gun shooting, and let's actually create that method. And to do this, we're going to need to instantiate some sort of prefab. So let's go up here. Let's create a new serialized field. Say private game object bullet. Whenever I instantiate something into the scene, I find it to be good practice to create another private game object so that you can manipulate the instance of this that we actually instantiate into the scene if you want to do that. So we're going to say private game object bullet inst for bullet instance. So let's take that and go down here. So finally, and remember to be using the Unity Engine.InputSystem namespace. We're going to go down here and we're going to say if mouse.current.left button.was pressed this frame. Well, if we press the left mouse button, then we are going to spawn our bullet. And we're going to do that by saying our bullet inst is equal to instantiate. What are we instantiating? Our bullet. And where are we going to spawn it? We should probably set some sort of serialized field that tells us where we want to spawn our bullet. So let's go up here really quick, create a new serialized field. We'll make it private of type transform called bullet spawn point. And let's say we are going to instantiate it at the bullet spawn point dot position. And we want our bullets to spawn into the scene facing the proper direction, meaning the direction that the gun was pointing. So let's say our gun dot transform dot rotation. Okay, and let's go back into our inspector and fill in these. Okay, so we already filled in our gun. Now we're going to need a bullet and a bullet spawn point. Let's create the bullet spawn point first. So I'm going to right click my bazooka game object here and click create empty. I'm going to call that spawn point. I'm going to give it a little icon here so it's a little easier to see, and we're going to move that towards the end of the gun there, just like that. Now we can drag in our spawn point. And for our bullet, we're going to need to create some sort of prefab. So let's do that now. Let's create a new empty called bullet. Let's reset the transform. I'm going to give that a sprite renderer so we can actually see it. And if you downloaded our tutorial asset pack, then what we can do is go inside there, go inside weapon and grab the capsule there. Let's drag that onto the sprite renderer. Just a little tip for whatever bullet prefab you're going to be using when you are wanting to shoot things in your scene, you will make things much easier on yourself if your bullet is always facing the right direction. You always want it pointing to the right. That's just going to make it so much easier for you, because I know that I could have gone over here and done 2D object, sprites, capsule, but that is going to be pointing up, and that just creates a couple of complications that I don't want. So I just threw a capsule into our tutorial asset pack that is facing right to make this much, much easier. So let's move that down here. That's definitely way, way too big. Let's make that 0.2. That's a little bit better. Let's also up the order in layers so that it's drawn on top of everything else. Let's make it something high like 50, and let's add a capsule collider to it. I'm going to change the direction to horizontal. And I'm going to make that a trigger. And it's usually good practice to put any kind of projectiles in their own layer. So let's go over here and click add layer. We'll say player projectile. And let's change the actual layer to player projectile. Okay, great. I'm just going to create a prefab folder. And I'm going to drag bullet in there. Now we can delete this. And now we can drag bullet into our bullet game object there. So let's test this. Our bullets are not going to move anywhere, but they should be spawning into the scene when we click, and they should be spawning in facing the proper direction. There we go. Now we could handle the bullet logic inside of this script here, but that's really not a good idea. When you're programming for game development, it's always a really good idea to try to create a new script every time you have a different job or task that you are trying to handle. And it'll be a little bit more clear towards the end as to why separating these things is such a good idea. So what we're going to do is we're going to create a new script. In our scripts folder, I'm going to create a new folder called weapons. And inside of there, I'm going to create a new script called BulletBehavior. And I'm going to add that script to our prefab game object. Okay, let's open up that script and get rid of the startup stuff. So what we're going to do in BulletBehavior is right in the start, we are going to set the velocity of the bullet to be in its transform.right, which is basically its facing direction based on how we instantiated it into the scene. And I forgot to add a rigid body to the bullet, so let's do that first. So inside our bullet prefab, let's add a rigid body 2D. I'm going to move that up here. We do want it to be dynamic. We do not want any gravity. By default, discrete collision detection should be okay, but if your bullets are going super, super fast, then you are going to need to change it to continuous. It really depends on your game's needs. We are going to change interpolate to interpolate so that it always looks like it's moving very, very smoothly. And let's go back to BulletBehavior. Now, first off, let's just grab a reference to that rigid body component. Call that RB, and we'll grab that component in the start function. So what we're going to do inside of our start function is immediately we are going to call a set straight velocity function. Okay, and let's actually create that right below. And that is really just going to be our rb.velocity is equal to our transform.right times some sort of speed. So let's go up here. Let's create a serialized field, private, float, normal bullet speed. Let's default that to 15 and bring that down here. So right off the bat, you can see that this is working nicely. However, every time we shoot something, there is a cloned bullet in our hierarchy, and that list is getting longer and longer because they're just staying in the scene forever. So what we want to do is make sure that those bullets destroy themselves after a certain amount of time. So right after grabbing our rigid body, we're going to call some sort of set destroy time function. And let's create that down here. And that's going to be very, very simple. We're going to say destroy this game object after how much time? Well, let's set up a serialized field up here. Serialized field private, float, destroy time. Let's default that to 3 seconds and put that down here. Now you can see as we're shooting, these bullets are going to start destroying themselves after enough time has gone by. There you go. Now it would also be nice to get this bullet destroying itself when it hits certain objects in our scene, like say our enemy or the floor. So let's set up a serialized field of type layer mask called what destroys bullet. Private layer mask what destroys bullet. And that is going to be used on our onTriggerEnter2D function. So I really like using layer masks in conjunction with collisions because it's a nice easy way to control what the bullet can and cannot collide with. However, the code to handle this is a little bit weird because we have to use what's called bitwise operators. I'm going to paste that in, and we have to code it this way because of the way that layers are set up in Unity. So the syntax is a little bit weird, but essentially what we are doing is making sure that what we have collided with is within this layer mask. So inside of here is where we would actually call all of our fun stuff, like, you know, maybe spawn some particles, maybe play some sound effects, add some screen shake, damage our enemies, and finally destroy the actual bullet. So to fill this in, we're just going to say destroy game object. And let's set this layer mask in the inspector. It is worth noting that in my environment here, my floor layer is set to ground, and I'm going to change my enemy to have an enemy layer as well. It also will not detect collisions if my enemy doesn't have some sort of collider on him. So really quick, I'm going to add a box collider 2D on there. Okay, there we go. Now inside of our prefabs, in our bullet prefab, let's actually set what destroys bullet to be enemy and ground. Let's test that. You can see they get destroyed when they hit the floor and the enemy as well. Awesome. Now let's have some fun with this and actually add a second type of bullet that we can shoot from our bazooka. And what's nice is we're not going to need to touch anything inside of player aim and shoot because we are separating our bullet logic from our player's shoot logic. So let's go back inside of bullet behavior and make a few changes. So what we're first going to do is add a public enum called bullet type. And we're going to make two types. One is going to be normal and the other is going to be a physics bullet. And let's grab a reference to that enum. Say public bullet type called bullet type. And what you will see now, if you add public enums onto your game objects, what you're going to get is a drop-down list in your game. So now we've got two options, bullet type, one called normal, one called physics. And we can make changes to the bullet behavior based on what the bullet type is. So enums are really, really cool and a really great additional tool to add to your game dev tool belt. So instead of calling this straight away, what I am instead going to do is create a private void called initialize bullet stats. I'm going to get rid of this and instead add initialize bullet stats. So what we're going to say in here is if bullet type is equal to bullet type dot normal, well then we'll call our set straight velocity function. Else if the bullet type is equal to bullet type dot physics, well then we'll have to create something else. So what I'm going to do before I go any further is I'm going to organize these variables up here a little bit better. I'm going to create a header called general bullet stats. And under that header, we are going to have our what destroys bullet layer mask. And then we'll create another header called normal bullet stats. Let's also put our destroy time under the general bullet stats. And now under normal bullet stats, we have our normal bullet speed. And let's create one more header called physics bullet stats. Let's create a serialized field, private float physics bullet speed. Let's make that something like 17.5. By the way, by adding these headers, what you're doing is you're making your script just look a little bit cleaner. Here's our general bullet stats header, another header over here, another header over here. So it spaces things out nicely and it adds some bolded text just to make this a little bit easier to read. So back in our bullet behavior, down here, back in initialize bullet stats, we need to set up some sort of method to set the velocity for our physics bullet type. So down here, I'm going to say private void set physics velocity. And we're going to say our rb.velocity is equal to our transform.write times physics bullet speed. And let's grab that method and add it right here inside initialize bullet stats. So far, all we've really done is create two types of bullets with very, very slightly different speeds. Let's make this a little bit more fun by also adding gravity to our physics bullet type. So to do that, we're going to go up here to our start function, and we're going to call some sort of method that changes our rigid body stats based on the bullet type. Let's call that set RB stats. And let's actually create that method. Private void set RB stats. So we need another if statement. So we're going to say if bullet type is equal to bullet type dot normal. Well, then our RB dot gravity scale is going to remain at 0. Else if our bullet type is equal to bullet type dot physics, well then our rb.gravity scale is going to equal some sort of gravity value. And let's actually go up here and create a serialized value. Serialized field, let's create a private float physics bullet gravity. And let's default that to 3. And let's grab that and plug it into our method. There we go. So now right in start, right when our bullet has been spawned into the world, we're going to grab our rigid body. We're going to set the destroy time in case it hits nothing. Then we're going to change its rigid body stats based on the bullet type. And then we are going to actually initialize the bullet velocity based on the bullet type. So let's test this out. So first we'll make sure that our bullet type normal is still good. That looks totally fine. And now let's try bullet type physics. All right, there we go. That's working nicely. Now it would be nice to be able to get these bullets to be rotating in the actual direction that they are moving. That'll make it look a whole lot nicer. And we're going to do that inside of our fixed update method. So we're going to say if our bullet type is equal to bullet type.physics, well then we're going to rotate the bullet in the direction of the velocity. And we can do this very, very easily by saying the transform.write is equal to our rb.velocity. Let's test that. So bullet type physics. Beautiful. Look at that. Now let's get these bullets actually damaging our enemy. And I'm going to show you in the easiest possible way, and it is also the most flexible. So our enemy literally has nothing, just a box collider. Inside our scripts, I'm going to create a new folder called enemy. I'm going to create a new script called enemy. And I'm going to leave that blank just for a moment, but I am going to add that script to our enemy. Now in scripts, I'm going to create one more folder and call it interfaces. And inside there, I'm going to create a script called Damageable. So this will be the shortest script you've ever seen in your life. Let's open that up and get rid of this startup stuff. Let's get rid of MonoBehavior and the colon. This is not a class, this is an interface. And what we're going to do is say public void damage. And let's pass in a float called damage amount. And that's all we need for this script. Let's go back to our enemy script. So here is how an interface works. We are essentially going to be able to add it to this enemy class, just like MonoBehavior here. Right beside, we're going to add a comma and add Damageable. You're immediately going to see that that gives you an error because we are not implementing our interface. Anything, this is a method here, right? Because it's a public void. Anything that we add into an interface has to be implemented into whatever script is implementing that interface. Doesn't matter how many methods are inside of this interface. If we want to add this interface to enemy here, we have to implement every single one of those methods, even if they're blank and we don't actually do anything with them. So we can add that by right-clicking, going to quick actions, and just implement interface. All that's going to do is create an actual public void damage float damage amount. It'll make it match this exactly. So now we have a damage function inside of our enemy. I'm going to very quickly add some health in there. Okay, so we've got a serialized field, private float max health. I'm also going to create a private float called current health. And in our start function, we're going to make our current health equal to our max health. And inside of our damage function, we can actually apply some damage by saying our current health is minus equal the damage amount. And if our current health is less than or equal to 0, well, then let's just destroy this game object. Now, this seems counterintuitive at first because we had to create a whole second script just to be able to add this damage function to our enemy. Why would we do it this way? It seems really weird. And the reason we do it that way is if we go back into BulletBehavior and we scroll down to our onTriggerEnterToD function right here at the damage enemy part, normally you would be trying to grab a reference to this actual enemy script here to apply the public damage function. And that will work totally fine. We could do that, except what if you have multiple things in your scene? What if we have barrels and tables and chairs and just other breakable things throughout the scene that we want these bullets to be able to destroy? If we're grabbing a reference to our enemy script, that is not going to work. And if you start throwing in a whole bunch of if statements, trying to find the tag of the game object that you're damaging, then every single time you want to add an item into your game that is damageable, you're going to have to go back to this BulletBehavior script and you're going to have to add new if statements and all of that stuff. And it's just a pain. What we can do instead is not look for the enemy component. We can look for the Damageable component. We're going to grab Damageable, called Damageable is equal to collision.gameObject.getComponent Damageable. And then we can say if the Damageable does not equal null, then we actually damage our enemy. So Damageable.damage. And finally, what's our damage amount? Well, let's throw up a couple of floats up here as well. Let's actually separate this out so that we can apply different damage amounts based on whether this is a normal or physics bullet. So under normal bullet stats, let's create a serialized field, private float, normal bullet damage. Let's default that one to 1. And under physics bullet stats, let's go over here and create a serialized field, private float, physics bullet damage. Let's default that one to 2. And then let's just create a private float called damage. And we can update this damage float to be equal to either this or this when we actually initialize our bullet stats. So if our bullet is equal to bullet type.normal, we can say our damage is equal to normal bullet damage. And if it's a bullet type.physics, well, then our damage is going to be equal to physics bullet damage. And then under Damageable.damage, we can just add our damage float. Let's test that. So with the physics, this should kill him in just 3 shots. Nice. And with bullet type normal, it should take 5 because we set that to only equal 1 damage. Awesome. There you go. So again, we could make these bullets damage absolutely anything that we want in the scene as long as we are adding the Damageable interface to whatever class we want to actually call damage on. Our shooting and our bullet behavior is completely separated, so you could add in as many different bullet types as you want, and then just set that in the inspector, and you won't have to change anything in player aim and shoot. So there you go, guys. Honestly, thank you so much for choosing this video to learn how to shoot in 2D in Unity. I really want YouTube to like me more, so if you liked this video, then please give it a like. Be sure to post any questions in the comments down below and let me know if you have any ideas for any tutorials you would like to see me do in the future. Thank you so much, and I hope that you have an amazing day.